Hello, today let's study a new material, a new building material which is being most widely used, which is concrete or cement concrete. It is the most versatile material, and the cement concrete has attained the status of a major building material in the modern construction industry. As we studied the different materials, the major constituent of the cement concrete is one is cement, the other one is aggregate, and then you have water. Coming to the aggregates, you have the fine aggregates, which is mainly the sand, and then the coarse aggregates, which are mainly the broken stones. When we dealt with the stones, I've already explained. Basalt rocks have been crushed and broken down and is used as the coarse aggregates in concrete. And then you have the water. Okay, now let's see the important functions of these ingredients. First of all, cement, we've already studied about cement. Okay, cement is the binding material. It is mainly used for binding all the other constituents. Proper binding of the aggregates, you need cement. Okay, and then mainly ordinary Portland cement is being used. Again, coming to aggregates, you have fine aggregates and coarse aggregates. Aggregates, they must be hard, durable, and they must be clean before using it in concrete. Okay, they must be free of organic components. And coming to the size of these aggregates, you have fine aggregates and coarse aggregates. Fine aggregates are those which passes through a 4.75 mmc, that is generally the size of a sand particle, and which is retained on a 0.075 mmc. Okay, and then mainly you were using river sand, etc., but since it was stopped, mm, we've been using quarry dust and crushed rocks now. And then for coarse aggregate, all the aggregates which is being retained on a 4.75 mmc is classified as a coarse aggregate. Okay. And then you have water. Why do you have water? Water, only at the presence of water, the hydration of the cement particles takes place. If you are taking the cement as such, it is not having any binding property. The moment you add water to the cement, what happens? The cement starts its hydration, exothermic reactions, and then bind the aggregates, the fine aggregates and coarse aggregates together, and they form a hardened mass. Okay, now we need to learn some of the terms which is related to this concrete. First of all, let me tell you, initially after just mixing of the concrete, of the constituents, okay, the concrete is freshly prepared concrete. After 24 hours, if you go look at that concrete, then you can see it gets converted into a hard mass or else hardened concrete. The properties for both of them is going to be different. Okay, some of the terms which is related to the fresh preparation of the concrete. When you are freshly preparing the concrete, these are some of the properties that you need to take into consideration. First one is segregation, defined as separating out of the constituents such as these aggregates from the concrete mix during the time of transportation is known as segregation. Second one is workability, the ease with which you can mix the concrete, transport it to the required place, and place it in position. Okay, generally workability increases with the increase in water content. If the water content is more, then it is more workable. You can work on it, you can work on the mixture more easily. Okay, and then next term is concrete bleeding. Bleeding of the concrete means it is the separation of water or mortar from the freshly prepared concrete. Okay, that is the water or mortar thing gets separated out and it comes on the top. Hmm? That is known as bleeding. These three terms or these three phenomena must be taken into consideration while you prepare the concrete. Okay, next you can just go through the advantages of concrete. It is a very hard mass, it resists perviousness. Okay, you can then go through the disadvantages. Just go through that. And then properties of the hardened concrete. Once the concrete becomes a hardened mass, then it is right to be in use. Okay, and then you need to know the strength of that concrete. Generally, the you have different grades for the concrete. As we have learned the different grades of cement, we have different grades of concrete. Hmm? The different grades is denoted by M5, M10, M15, 20, M25, M30, 35, 40. Okay, the letter M denotes the compressive strength at 28 days after casting the concrete of a standard cube of 15 centimeter size. Okay, we are going to cast a concrete cube with a mixture of cement, sand, and aggregates, coarse aggregates, and then water. And then you are going to make cubes of size 15 centimeters. And then after 28 days, you are taking it out from water, and then you are checking the compressive strength of that cube in a universal compressive testing machine after 28 days, and then the compressive strength value is gives you the grade. Okay, if it is M5, it should give a compressive strength of 5 Newton per mm square. M10, should give a value of 10 Newton per mm square. It goes like that. Okay, now what is this combination, the constituent of this M5? How much cement, how much sand, and how much coarse aggregate you need to select? It depends. It varies for different grades. So you can see if you are using an M5 grade of concrete, the ratio of the concrete mix goes like 1:5:10. That is, if you are taking one bag of cement, you need to take 5 bags of sand and 10 bags of coarse aggregate. Okay, that gives you a M5 mixture of concrete. Okay, and then combine it with the adequate quantity of water. And if you are making a cube of 15 centimeter size and testing it after 28 days, what must be the strength of the compressive strength of that cube? It must give a compressive strength of 5 Newton per mm square. Again, M7.5 Newton per mm square, you can see. The ratio of the mix is 1:4:8. That is, if you are taking one bag of cement, you need to take 4 bags of sand and 8 bags of coarse aggregate. And the compressive strength, after testing it after 28 days, then it must give a compressive strength of 7.5 Newton per mm square. And this continues. Okay, you can see, go through that. Again, then another property is the durability. It must be durable against all wear and tear, weathering actions, chemical actions, etc. It must be completely impermeable. Okay. Again, depends on the constituents. There are chances of the shrinkage of the concrete. Again, it must be fire resistant, resistant to wear, and then proper bone strength should be formed when you are using the concrete with reinforced concrete. Okay, we'll come through that later and you'll understand. So this is not there in your syllabus, but you will have to understand the different processes in concreting. You can just go through it. Okay, first you have the batching operation, that is depending upon the grade of the concrete which you wanted to adopt for a particular construction site. You can mix up the ingredients in a batching plant. Okay, you mix up the ingredients. You can either do it manually on the ground, but for large scale construction, you do it under a batching plant. You mix, you take up the ingredients correctly depending upon the grade, and then you have a cement silo cement stored here, and then you weigh up the grade of the concrete according to the grade you need. And then you have the mixing plant. Mixing at generally you have a mixing done at the field using, you have hand mixing using shovels, or else you have a machine mixing like this. Okay, you have a machine mixer. Sometimes the concrete you are using it for the construction will be ready mix concrete. That is, there are plants, RCC plants, ready mix concrete plants, where ready mix concrete plants wherein the concrete is completely prepared and then transported in trucks. Okay, you might have seen this in roads. Okay, this transit truck mixes, what they do is they just do the batching and mixing at the plant, and then they put it into these trucks. The complete mixing up operation is carried out in this truck. As you have seen, the trucks continuously rotate. Okay, and then the next operation is placing. That is, you're going to place the concrete. Here you can see from the trucks it is placed to the required position. Okay, you have to place the reinforcements. Reinforced cement concrete. If you're going to make a reinforced cement concrete, you place the reinforced steel bars and then you pour the concrete. You can see this. You might have seen such operations being carried out at the construction site. And the next one is compaction. That is, you need to make sure that completely you remove the air bubbles which is being there. Okay, while placing of the concrete completely, you with the help of vibrators you compact it thoroughly. Okay. After compaction, the next major step is curing. It is the operation of keeping a freshly placed concrete moist for a particular period of time. Generally, for 28 days, 14 to 28 days, you need to completely water the concrete. That is why after the construction of your of a particular building, curing is carried out. Why is it carried out? It is because the water which is given for hydration may be lost due to evaporation. So once the water is lost, the cement again loses its property. It need water to complete its hydration reaction. So continuous water is needed. So initial water which was given may have evaporated. Okay, so in order to compensate that water, you will continuously you'll have to cure the concrete. Okay, here you have different type of curings. Water curing. Okay, you can see water curing, and this one is a membrane curing. Okay, gunny bags, membrane curing, you have special membranes, chemical membranes, which has the capacity to retain the water. Then you have gunny bags. You might have seen wet gunny bags have been laid over the concrete. Then ponding. This is the method. This is another method of curing. You might have seen this happening in our badminton court in MEC. Curing. They have made ponding structures in the sides and then they laid water over it for proper curing. Okay. And then only after this 14 to 28 days of curing, the concrete completely attain its strength. Now you will have to learn a major difference between a plain cement concrete and a reinforced cement concrete. Now, if the mixture is just cement, sand, or aggregates and water, then it is known as a plain cement concrete. Whereas if you are using reinforcement, reinforcement is nothing but this steel. If you are using the steel, then it is known as a reinforced cement concrete. Okay. The main advantage of reinforced cement concrete is that since you are placing steel, steel can take tension forces and therefore it can also take the tensile stresses which is coming over the beam or the slab, whatever it is. Okay, if you are just using a plain cement concrete, it takes only the compressive forces. Okay, then you can study the uses and application of these PCC and RCC. Just go through this. Next, another important topic is the types of concrete, which is very important for your syllabus. As your syllabus point of view, it is very important. The types of concrete. In types of concrete, first you have the waterproofing concrete. Okay, especially you want such a concrete in the case of a storage tank, swimming pools, reservoirs, etc. Okay, and high quality of the Portland cement must be used. Clean and non-porous aggregates must be used, and better water proofing can be achieved if you are replacing this Portland cement with the help of hydrophobic cement. Next is colored concrete. Colored concrete you can get it in three different ways by using one is by using colored cement, second one is using suitable coloring pigments, and the third method is using aggregates having the required color. You can get the colored concrete. Okay. For different works. Again, you don't have to paint the surfaces if you are using the colored concrete. Again, you have lightweight concrete. The normal bulk density of the ordinary cement concrete is 28 kilonewton per meter cube. In order to decrease the density of the concrete, you are going to add some forming agents. Okay, you add some chemicals to develop some form. Okay, and another method is you can replace the aggregate with the help with pumic stones. Pumic stones you might have seen. You might have been using pumic stone for scrubbing your food. Okay. Again, if you are replacing it with the pumic stone, the aggregates if you are replacing, then you get a lightweight concrete. Okay, you can see this. The weight of the concrete, lightweight concrete versus the cement concrete. Okay. And these lightweight concrete is very mostly used in the multi-story building as the height increases. So, generally, we go for the lightweight concrete for multi-story buildings. Towards the top stories, we go for this lightweight concrete. Okay, and then you have the no fine concrete. No fine concrete. Generally, you eliminate the fine particles, which is the finer particles. You can eliminate cement because cement is the binding particle. You eliminate the sand particles or the fine aggregate. Okay, it may reduce the chances for shrinkage of the concrete, and it can provide a better insulating property. Okay, you can use the fine concrete like this. On top you can have the concrete, and then one layer you can give a no fine concrete. Okay, and then you have the fiber reinforced concrete. Instead of reinforcing it with steel, you have fiber reinforced concrete. You can reinforce using materials like asbestos, glass, nylon fibers, square fibers, etc. Okay, researchers have been going in this field, and then it has been uh, found out that they are more durable than the ordinary reinforced cement concrete. Okay, and more crack-free structures can be formed. Here it is some pictures of a fiber reinforced concrete. You have cement, sand, and coarse aggregate and water, and instead of the reinforcing steel, here you use different fibers. These fibers can be asbestos, glass, etc., coir, etc. Okay, next is you have the pre-stressed concrete, which is being widely used. All the beams or all the girders which you have seen in the metro pillars or in the bridges, Palarivattam bridge, flyover bridges, all you can see this pre-stressed concrete. You might have seen such bolts coming out of this. Okay, pre-stressed concrete, what you do is you are tensioning steel wires which is being placed inside the concrete. It is not the reinforcing bars. You are having tensioned wires inside that. You are all, and then what you do is you are stressing it. Okay, from outside you are giving stress to these wires such that what happens is that it turns the beam to be or the girder to be strong. Okay, you can see the first two pictures denote a reinforced cement concrete. What happens is that since it is reinforced concrete, once there is load over the beam, what happens is that there is tendency to sag and crack. Now, the third and the fourth picture is a beam which is pre-stressed. Once you are having a pre-stressed bar, you are placing a steel rod inside and then you are stressing the beam. Okay, that is you are stressing it by stretching the rod. Okay, just imagine you are you are placing a. It is just similar to that of a rubber band. You are stretching it out. Okay, and what happens when you leave the rubber band? It goes inside. Okay, similar to that, you are pulling out or stressing out the steel rod which is placed inside. And once you are leaving that, what happens is that it squeezes the concrete and it makes the beam very compact and very strong, which prevents the cracking of the beam. Okay, these are the topics which is coming under concrete. Just go through that, and if you have any doubt, just come to me.